Before we start level 3 balancing, I want to show you how to visualize polyatomic ions. This will help if you do the math or the box way. So we've got just some statements about what polyatomics are. It is a group of atoms that has an overall positive or negative charge. When these ions are in chemical reactions, they stay together as a group on both sides of the chemical equation. Balancing these equations with polyatomic ions is easier if you keep them together as a group rather than separating them into their individual elements. So this is just a list of some common polyatomic ions. When you see some of these as groups and that you see that they're the same on the reactant and product side, their group hasn't switched. It's just easier to think of them as a group and not split them up into their individual elements. Here are some sample formulas with polyatomic ions. And I'm just going to show you how I want you to visualize these, because sometimes it's hard to see them, to know what visual you are supposed to have in your head with the parentheses. So for this one, we got Mg. Whenever you see parentheses, that means make branches. So I have a 2 outside of my parentheses. I'm going to make 2 branches. On the end of each branch, I'm going to write the group that's inside the parentheses. And when I do my inventory in this formula, I have 1 Mg. I'm going to think of OH as a group, and I have 2 groups of OH. The next one, I usually just leave Al2 as Al2. Some people like to write it out 2 times. That's your choice. We've got a 3 outside the parentheses, so that means 3 branches. At the end of every branch, I write what's inside the parentheses, which is SO4. And I see that I have 3 groups of SO4 and 2 Als. The next one, there's a 2 outside the parentheses, that means 2 branches. Two groups of CN, 1 Ca. Alright, on the next one, again, 2 branches. This polyatomic ion has 3 elements, C2H3O2. But I don't have to memorize that. I just know that whatever's in the parentheses goes at the end of each branch. And I've got 2 BAs and 2 groups of actually I have 1 BA and 2 groups of C2H3O2. In the next example, I have the only polyatomic ion that is positive that we're going to use. So whenever I have NH4, I kind of make my branches go the other way. And I see that I have 3 of them, 3 NH4s. PO4 is also a polyatomic ion. I can circle it, and there's 1 group of that. It looks like this next one, that little number is supposed to be a 2. So I have BE3. 2 branches for PO4. So 3 of these, 2 groups of PO4. I also want to do a little bit of practicing of drawing the formulas with polyatomic ions, but also incorporating coefficients. So first, the formula Al. I have 3 branches, the 3 outside the parentheses, and at the end of each branch I have a ClO3. When I have a subscript of, or a coefficient of 2, I need to write this a second time. And before I do my count, I circle all my groups, and I can easily see I have 2 ALs and I have 6 groups of ClO3. Next example, again I have 3 branches. And this time my coefficient is 3, so I'm going to draw this 3 times. And this is just a visual way to see that I have 3 ALs. And when I look at OH, I want to look at my groups. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of OH. Alright, my last 2 examples, I've got 2 branches on this one, ClO at the end of each branch. My coefficient is 2, so I'm going to draw it twice. And I've got 2 Mgs and 4 groups of ClO. The last example, there's that NH4 that I mentioned you can only have at the beginning. So you got to reverse the way you draw your branches. And the coefficient is 2, so we're going to need to draw it twice. And if I do a quick count, I see that I have 6 groups of NH4 and 2 Ns. And that's how you should visualize formulas when you see parentheses and you know you have polyatomic ions.